Welcome back, Pre-Algebra. We are in our final lesson of the book. We are in lesson 123. I am so proud of you guys for sticking it out and getting all the way through. This is not going to be a hard lesson. We're going to talk about numerals and numbers and the number system. So a number is an idea. That is something that we need to know. A number, it's just an idea. It's a thought. So if I have three things right here and I count them, if I have three circles, that's just an idea, right? The idea is that I have three things. A numeral is the symbol that represents that idea, right? A numeral equals the number 3. It equals this symbol that we have chosen to take the place of this idea. That's all it is, right? It is just a numeral, it's just a symbol. When we want to express the idea of 3, we write that symbol, and the symbol is not a number, but is a numeral that makes us think of the number. The ancient Romans, they used Roman numerals. They used this when they thought of the idea of this many things. There are many numerals for 3. All the following numerals have the value of 3. We could say 2 plus 1. That's the same thing as 3. We could say 14 minus 11. That's the same thing, or the same idea as 3. We could say 6 divided by 2. That is the same idea as 3. Each of these groups of numerals can also be called a numerical expression. We see that the value of a numerical expression is the number that the expression represents. Since all of these expressions represent the number 3, we say that each of them has a value, or that they equal 3. The distinction between a numeral and a number is often helpful. For instance, we cannot add the fractions 1 over 4 plus 1 over 2 because we understand that in their present form, the denominators are not the same, but we can add the fractions if we change the numeral to get a common denominator. So the numeral is just a representation of the idea. And we understand with this expression that the numerals have to have something in common for them to have a value that makes them relatable. So what we would do is we would change this fraction here. We would change the numerals so that they have a value that is relatable. That would then makes to where we could add these together and we would have 3/4. We didn't change the number. We changed the numeral used to represent the number. It still has the same value because 1/2 and 2/4 represent the same number. From this, we see the distinction between a number and a numeral. A number is an idea, and a numeral is a symbol. So let's talk about the number system itself. Let me clear this out for us. To count the members of your family or the desk in a classroom, you use numbers, right? We count with those. We say we've got 1, 2, 3, 4, 5, 6, right? We use the numerals to count. We call the numerals that we use to count with natural numbers or counting numbers. My pen wants to be a pain, so I'm going to type instead. So natural numbers are the set of numbers that starts with 1, 2, 3, 4, 5, and so on, right? And this little ellipse thing right here, Those 3 dots, those are, it's called an ellipse, and it signifies that those numbers go on and on forever in that direction. Whole numbers start with, the set starts with 0. And then it goes 1, 2, 3, 4, and so on and so on. So the only difference between natural numbers and whole numbers is that we begin with 0 instead of 1. Natural numbers are the numbers we start counting with, and we always start counting with the number 1. We don't start counting with 0. But 0 is a whole number, and so it's included in the whole number set. The next type of numbers that we have are integers. Integers are unique in that they go on and on in both directions. So you have an ellipse at the end or at the beginning, and they start with the negative numbers. Let's say -2, -1, 0, 1, 2, 3, and so on, and so on, and so on. So you see these numbers kind of start in the middle at 0, and they go on and on in each direction. They go to the positive side, and they go to the negative side. This is your number line. The integers are the tick marks on your number line. Now, then we have something called rational numbers. And they include everything on the number line, including the spaces in between the numbers. So rational numbers are integers plus fractions and let me see how to say this. Non-repeating, or non-terminating decimals. So if the fraction repeats or it terminates, then that decimal is included, right? So actually the non wouldn't be included. So repeating or terminating decimals, repeating and or terminating decimals, because some might repeat and terminate, some might just repeat, some might just terminate, but what is not included, there's another type of number, and that's called irrational numbers. And irrational numbers are simply non-repeating, non-terminating decimals. That's what they are. So let me give you an example. Let me move this over here. Or I guess example is the wrong word. Let me give you an illustration of how the number system works. So we have, think of it as like, this is the world, even though it's a square. Within our world, we have numbers, and we call those numbers real numbers. They are for reals. They are the reals, the real number system. So reals is all the numbers, all of them. Every number possible is included in the reals. And then from there, we have two different types of numbers. We have irrational numbers, and we have rational. An irrational number is, as I said, a non-repeating, non-terminating decimal, or its symbols. So think about the symbol for pi, right? That is an irrational number. Pi goes on and on and on, and it never ends. It never repeats, and it never ends. It just has this long string of numbers. So that would be an irrational number. If you have the decimal that represents 1/3, you would have 0.333333333, right? It's a non-terminating decimal, but it repeats the 3. So we can't include that under irrational. We include that under rational because we can wrap our head around that. We can write that like this, and it's done. So that's what makes it rational. It can be written as a fraction. Now, if a decimal cannot be written as a fraction, it's because it doesn't repeat and it doesn't terminate. We have to be able to end it, to write it with an ending in order for it to be considered a rational number. So a number, even if we wrote this as a decimal, we could write it like this and put the repeating sign over the top of it, and we would know what that is. We would be able to understand what the value of that is. We would know that if we cut a pizza in 3 equal pieces, that would be 0.333333 repeating of the pizza, or 1/3. So that's what makes that rational. We can write it as a fraction, or we can write it as a repeating decimal. Even this fraction here, 1/2, we can write it as a terminating decimal because we know that it is 0.5. 0.5 is the same thing as 1/2, 1 divided by 2. So that's what includes those in the rational category and keeps them out of the irrational category. Rational includes fractions, and they include repeating or terminating decimals. If a decimal like pi is non-repeating and non-terminating, you have 3.14, and then it goes on and on and on and on and on forever and never repeats or stops, that's an irrational number. There are other irrational numbers. This is the one that we'll use the most, so that's the one that I'm calling out. Now, underneath rational numbers, these are the numbers that are in between your integers, but included in rational numbers are the integers, or the numbers on the number line. Now, the integers include whole numbers because 0, 1, and all the positive numbers are on the number line, and then the whole numbers include the natural numbers, or the counting numbers, because 1 to infinity are included in the whole numbers on the number line. So that is how the system works. All the numbers that we can understand or write with an ending are rational. All of the numbers that are whole numbers, positive or negative or 0, that can be written on the number line are integers. Whole numbers are included with the integers starting at 0 and going to the right, and all the natural numbers are the numbers on the number line starting at 1 and going to the right that are all positive or counting. We call these counting numbers. And that is how our number system works. And that is all we have for, I take that back. We have one practice problem. So let's take a moment, write all this down, and then I am going to clear the page and we'll do our one practice problem. Actually, you know what? I think we'll just do it right here. Let me write that up here for us. All right, 121.1. To which number set do the below numbers belong to? So -3 is on the number line, right? So that means it is an integer. So that would be an integer. And integers fall under rational numbers, so it belongs to the rationals as well. And all numbers belong to the real number set because all numbers are real. So it belongs to integers, rational, and reals. What about 2/3? 2/3 would fall under rational because it's a fraction. So we could say rational. And all numbers are reals, so rationals and reals are what 2/3 would belong to. And that is all we have for lesson 123, and I will see you at the final exam.